Okay. So the first part was the objective support. The first part was to provide you some key figures about primary energy consumption, but also about renewable production and so on, and to give you some to explain you why the electricity and gas prices are increasing right now, and to explain you how is it possible to build an energy grid offer and how you can do that. With the second part, it is more focused on how to price an energy offer. So this is just the question that you ask: how is it possible to make a fixed price? And yes, the price is fixed in the energy market and so on. But at the end, as customer, as residential customer, most of the time we are buying a fixed price contract. And how is it possible that we can buy that type of contract? So the energy supplier has some techniques to do that, and I will show you the basics to do that. Of course, it is much more complex in reality. It's to give you some insight about that. So this is just what I said. And first, we will see how to make an energy offer based on the market. So by buying energy to the market, and to transform variable prices of the energy market into fixed price. And we'll also see how to make an energy offer by directly buying the energy to the producer. What do you think of the evolution of the electricity and gas bills over the last decade in terms of price? So we buy electricity and gas to energy supplier. What do you think of is it constant? Do you think, or maybe it has decreased over the last decade, the price of energy, or maybe it has increased?
I think that we have seen on the previous slide that it has decreased, but for this year,
it should increase. So that's for sure. Probably this year, on average, the electricity and gas bills will increase. But for the last decade, in fact, it has increased. So here it was in 2006, and here it is right now. And here it is for the best. If you each month you select the best energy supplier, so that provides the cheapest offer. And here it is on average, and you can see that on average it has increased, but it fluctuates a lot. Sometimes it is smaller, sometimes it is higher. You can see here it is in the COVID crisis. In the COVID crisis, the demand has a little bit decreased, and so the price of energy and so on. And right now it is increasing. But on average, it has increased, but yeah. And here it is the same for the gas. No, the gas is a little bit different, sorry. Here you have the economic crisis, 2008. Then after the economic crisis, the price decreased a lot, and then it increased, and then it has fluctuated. On average, it was constant, and it has decreased. During the COVID crisis, the price decreased, and right now it's increasing. So for the electricity on average, there is a trend, an increasing trend, but for the gas, it's a little bit more difficult to say something over the last decade. Sometimes it decreases and sometimes it decreases. So for next year, for sure, it will increase. And here are some key facts. Here it is the increase. So by comparing an average bill for electricity for a Belgian household, between last year and now, probably the increase will be of 9% right now. And for gas, almost 20%, so it's quite huge. And here it is the amount of the average electricity bill and gas bill for a household. So on that amount, if there is an increase of 20%, for some people, it's a lot. For some, it's nothing, but for some people, it's a lot of euro. It's not easy. And probably due to the electricity and gas price increases during this winter, this will be much more worse for a lot of people. So just a small reminder about the energy component of the electricity and gas bill. You have, of course, the energy part. So you need to pay for the energy, obviously. but also for taxes and distribution and transportation costs. And as an energy supplier, you cannot do anything about that part because the taxes, they are fixed. And also the transportation distribution cost, and you just add them to energy part. So when you are an energy supplier, what you can optimize. What you can optimize is the energy part. And so we will focus on the energy component and to see how we can make a fixed offer. In terms of physical fluxes, so the energy producer produces energy, it goes to the main grid, TSO, DSO, and then it goes to the consumers. In terms of financial fluxes, remember, we buy energy to the supplier, so our money goes to the energy supplier. Sometimes it goes to the market, or sometimes it goes directly to the producer, it depends. But for the energy part, you have several components into the energy part. You have the energy, but just the energy. You have some balancing fee. You have sometimes, if you want to make a green offer, you have to buy guarantee of origin, so it will have a cost. And you have also what is called capacity. And so we will go through each subcomponent of the energy part. And as an energy supplier, you can do something for all components to try to optimize at the end the price for the energy. So you know already now the difference between the fixed and variable price contracts. And I already gave you the answer to that question. But so when you have a constant energy component, it means that you pay most of the time an annual fee, which is called abonnement in French, an annual fee. You pay for an annual fee. Whatever you consume, you pay for an annual fee. And then you have a fixed price for each kilowatt hour that you consume. And so this is a fixed contract. And the price is fixed for an entire year. So it means that A and X, they do not change for 1 year. And so it is a fixed contract. And the pros of that of this contract is that it will have less aversion for the risk, because as right now the market is fluctuating a lot, and with that kind of contract, as a customer, it does not change anything for you. And so if the price, however, if the price is high as a contract settlement, of course, we'll pay a high price for an entire year. But you have less aversion to the risk. On the other hand, you can have a variable contract, and when you have variable contract, most of your time you pay also for a fixed fee, the abonnement, fixed fee for an annual fee. But the variable part here is not fixed. It is indexed as something. So you have two components. Sometimes C is just 0, but B is fixed, but it is indexed. And the index may be, for instance, the day-ahead prices. So it means that if the day-ahead prices of electricity is fluctuating, this part will be fluctuating, and at the end, what you pay will fluctuate. So if the market price is good, for you it's good. If the price is decreasing, you will pay less. But if the price is increasing, obviously you will pay more. So the choice between these contracts depends on your risk aversion as a customer. What do you want? Maybe it completely depends on what you want. In fact, at the end, there is not a good solution. It depends on what you want. But here in Belgium, almost 60%, 65% of the contract in electricity and gas are fixed price. But I think also that most people do not even know that they can have access to variable price. So I don't know if it is really representative of the risk aversion of the Belgian people. But now that you know that, maybe next time you will settle your contract, maybe we'll discuss with your energy supplier. But so right now, with what is happening, if you have a fixed contract, it's quite nice, because if it's variable contracts, you are paying a lot. But if your fixed contract ends in 1 month, obviously there will be an increase. So at the end, everybody will pay the increase of the price. So you already know the actor of the energy market. We already talked about that. So now we focus on the sub-energy component. So only the energy. So if you look at the energy market here, as an energy supplier, you can buy energy on the energy market. You can buy different kinds of energy products. So you can buy calendar products. So a calendar, it means that you buy energy for an entire year, a fixed quantity of energy for an entire year. But you can buy also energy for 1 quarter, for 1 month, a week, or a day. And if and also you can buy energy on the spot market, on the day-ahead market, and in the intraday market. So when you have access to the energy market, in fact, you have access to a lot of kind of energy products. And you can also buy directly energy to producer, but in that case, you do not have this kind of product. Do you have any idea, if I am an energy retailer and I want to buy energy on the market, why I would like to buy different kind of energy products? Do you have any idea why? Yes.
Well, simply because the consumption will not be constant during the whole year, not during the whole month.
Yes, obviously it is just that, because almost everybody has a variable consumption. Obviously, when we have a flat or a home, when we want to eat that flat or home, obviously in winter we will eat more than during summer. So if I am an energy supplier and I have a lot of residential consumers, I expect that my portfolio, the consumption will be much more higher in winter than in summer, just for the gas part. And for electricity, it also fluctuates. You have a peak consumption, for instance, in the evening, because we all come back almost at the same time at home, because during the day we are supposed to work. Suppose it depends on people, sometimes we do something else, but most of the people are not at home during the day. And so they come back at home in the evening and you have a peak of consumption. It is the same thing in the morning. And during night, we are almost everybody sleeping at the same time. Some people are working during the night, but most of the people do not work during the night. So the consumption is not fixed and it fluctuates inside the day, but it also fluctuates between seasons and between months. So if I am an energy retailer, and if I buy only calendar products, it means that I will have a delivery that is fixed during the year. And I will have a problem to balance my supply and my demand. Sometimes I will have more energy that my consumers, customers consume, and sometimes I will have too much energy. And so the TSO will tell me, you're a balancing responsible party, you cannot do that. So you will pay a fine. And so I do, as an energy supplier, I do not want to pay fine, otherwise I will be booked. So that's why we buy different kind of energy product to try to match the supply and the demand. So and then there is also something else. It is to minimize the risk aversion. Sorry, because most of the time the future price fluctuates less than day-ahead prices. Because you could say, as an energy supplier, I buy everything on the day-ahead market. Like that, I can exactly match the demand that I will have tomorrow. It's much more easier to forecast the consumptions 1 day before than 1 year before. Because 1 year before, you do not know how many customers you will have in 1 year. But if you just wait for the day before, it's okay. You know your number of customers. You can forecast approximately the demand tomorrow based on what the forecast. You know if it will be a cold day or not. So it's much more easier to wait for the last time to buy the exact amount of energy that you expect. But if you do that and you buy everything on the day-ahead market, as this market fluctuates a lot, it's much more risky in a sense, because you don't know if the price will be high or not. And right now, for instance, the price is very high. But at the end, you have to sell this energy to the customer. And if you sell it to a fixed price and the price at which you buy the energy is very high, you will have a problem. So most of the time, the energy supplier also buy in advance a large quantity of energy to try to securize the price. So it means that here is the day of delivery. But so basically it means that most of the time the energy supplier has bought a quantity of energy, even sometimes 3 years ahead. So it estimates, it forecasts in 3 years approximately, I will have 1,000 residential customers on average, so I buy a quantity of energy. And then 1 year before, it tried to buy quarter price based on the energy consumption. Okay, now I know a little bit better my number of customers. I know that during the winter they will consume more. So I try to buy some calendar product. And you can do that 1 month before, 1 week before, 1 day before, and then at the end, you can just buy the difference on the day-ahead market. And so at the end, the price is a kind of mix. So the fixed price at which you will have your contract with the customer will be a kind of mix between the price of calendar product, quarter product, monthly product, weekly product, daily product, and the spot day-ahead market. So here it is the electricity calendar product for 1 year ahead. And so you can see that it fluctuates during the year, but most of the time it does not fluctuate a lot. And so you can see that if you compare that to the day ahead market, it is like that. And here you can see the difference between some countries. Belgium is in blue, France in gray, Germany in yellow, and Netherlands in orange. It's a little bit the same, but over the last year, the calendar prices was a little bit higher in France. And here you can start to see the increase that is happening. And it's the same thing for gas. You can see that the calendar prices, it fluctuates a little bit, but most of the time it's quite constant if nothing big is happening. Okay, so on one hand, you have different kind of energy product, calendar, quarter, monthly, daily, and so on. And on the other hand, you have your consumers. And you can find some synthetic load profile. What are synthetic load profile? They have a forecast of the consumption of different kinds of profiles. Because based on statistics made by the TSO and DSO, we know with quite a good accuracy how people consume energy. On average, over 100 and 1,000 of people, this is for over a year. So from day 1 to the last day of the year, you can decompose people between different kinds of profiles. So for instance, people that have a large consumption, people that have a small consumption, people that have a consumption that is different between the day and the night. Sometimes when you can pay a price that is different between day and night. And so they can statistically build this synthetic profile. And here you have the fluctuation between days. And here it is during the year. So here you have the summer. Here it is the 2 parts of the winter. And here it is synthetic profile for electricity. In blue, it is for consumers that consume not too much energy. So, and in red, it is for consumers that consume more energy, like people that have a big house. And here it is more fun for flat. And here it is for people that have a different price between night and day. And you can see that the consumptions fluctuates inside the day between week, because between weekend and not weekend, and between the year. And so based on this synthetic profile, as an energy retailer, you can forecast your consumption because you know how many consumers are in these categories. So if you know statistically how many consumers you have here, here, and here, and here, you can just make a sum, a weighted sum on that. And then at the end, you can forecast your consumption. And so with that, you can buy the electricity on the energy market based on the different kind of products. So here you have, for instance, I take a specific load profile, and I will show you how is it possible at the end to make a fixed price. So you have here your load profile, consumption profile over the year. So here is the number of days from day 1 from the last day. So it fluctuates between winter, summer, between weeks, and inside the day. And so you imagine you are 2 or 1 year in advance. You know that you will have some consumer that will have this kind of consumption profile. So one way is to say, okay, I take the average of that profile. So it is a constant. I take an average over the year, and I buy that amount of energy to the calendar price. So I buy this quantity of energy that is fixed during the year at the price of the calendar on the energy market that I can have. Okay. So it means that during the summer, I will have too much energy. and during the winter, I will not have enough energy. So then what I do is, okay, now I buy quarter products. So I take my profile, I take the difference between the profile and and the average over the year, and then I sell the difference on a quarterly basis here for summer, and I buy the difference here during the winter. And so like that, by buying then shorter time product, I will try to rebuild the synthetic load profile, but with different kind of energy products. So here I just stop it at the quarter, but in fact you will do that for the year, then on a quarterly basis, then on a monthly basis, then on a weekly basis, and then on a daily basis. And at the end, you will have just very tiny difference between the synthetic load profile and what you bought with the different kind of energy products. And the difference, you will buy it at the day spot market just 1 year, just the day before. And so the price related to the spot will be the balance, so the difference between what you already bought from all the energy products and what you need. And so sometimes you will buy the excess if you have too much energy, and sometimes you will sell the excess on the energy market if you already bought too much energy. So this is a recap. Here you have the original load profile. Okay, and first you take the average of that profile. You buy that to the calendar price. Then here you do not have enough energy, so you buy again to the quarter. Here you have too much energy, so you sell it to the quarter, and then you make the difference with the day-ahead spot price. And so at the end, the price is a sum of different fixed price. And so this is how at the end you can sell an energy offer that has a fixed price. And so you rebuild the synthetic load profile with different kinds of energy products. Did you understand the way it is done? Okay, so here it is quite easy. I just use the calendar of the quarter price. But in reality, they would use much more energy product. And sometimes imagine you were 2 years ahead, you bought energy at the calendar price, at a given price, and maybe 1 month after the price has changed. Maybe you will try to optimize by selling it apart to buy another part that is more advantageous for you, and so on and so on and so on. But basically, this is always the same technique. You have your synthetic load profile, and you try to match the demand with different kinds of energy products. And so you try to optimize like that the energy fluxes and money fluxes. So this was a way of doing a fixed price by buying on the energy market. Yes?
Earlier you said that Belgium knows more about fixed contract than variable contract. So why we cannot done that more ads about variable contracts? It's more simple for them to change the price according to the market instead of doing all those calculations.
But in fact, it's just a choice of a customer. Maybe I don't know how people behave here in Belgium, or in Europe, but I think that most of people, they do not want to have a price on their electricity or gas bill that fluctuates a lot. Because for you as a customer, it's very difficult to manage your money if you do not know what price you will pay for the next month. Because if you have a fixed price, you know that each month you will pay that amount of energy. You know how you will pay, so it's easier for you to forecast what you will pay in terms of energy. And for a lot of people, they do not like to do not know that, because sometimes if the winter they pay 100 euro or 200 euro, for them it is not the same thing. I think maybe it is that, but probably it would require to analyze that with more psychological aspect and so on to answer to that question.
We don't need to have a smart meter to the variable price.
No, not at all. Because
the old ones?
Yeah, sure. Yes, because the DSO, they know the quantity of energy that is going through the pipes for gas or through the grid for electricity. But when it is variable, it is not, it depends on the contract, but most of the time it is not a variable price on an hourly basis. The price does not change every hour. It may change every day or every week or every month. You know what I mean? But because if you want to make a contract with variable price on a hourly basis, yes, of course, you need a smart meter. If you do not have a smart meter, it's almost impossible, or it will be very difficult for the energy. But most of the time, the variable contract, the price changes every month. It does not change every day. They change the price every month. Okay. So this is the way of doing at the end a fixed price. Now let's have a look if we build an energy offer by buying directly to the producer. So let's take an example. So imagine in blue, this is a wind farm. So this is a production profile of a wind farm over a year. So here you have all the days of the year, and here you have the production of the wind farm in blue that has been normalized. And in red, you have the price of the electricity on the day-ahead market. So one way of doing a fixed contract offer is, okay, you discuss with the energy producer and you say, I can propose you to buy your wind power to the spot day-ahead prices. But maybe you would prefer a fixed price. And what I can do is, I buy your production at the price that is the sum of the product between on an hourly basis of the production of what you produce and the spot day-ahead prices. And so at the end, this integral, it will build a fixed price. So this is one way of doing it. And so you say to the producer like that, you know exactly the price at which you will send me the electricity. And me, I know exactly the price at which I will buy you electricity. And so, for instance, I made this calculation with that profile and the day-ahead spot price for the year 2017 for this production. And it resulted in a fixed price of 48 euro per megawatt. So for the producer, maybe it is depends on the day-ahead market, but imagine that in reality the day-ahead market will fluctuate and maybe the price will increase. Maybe for him at the end it will be less advantageous for this kind of offer, but on the other way it would be the opposite. So this is one way of doing it, but there are other way of or technique or more complex technique to do that. But this is a simple way of buying energy to producer and to build a fixed price. And so at the end, you can sell to the customer, okay, I can sell you wind power electricity at that price because I bought it at that price to the producer. And like that, you bypass the energy market. And the price is not related to the energy market. Did you understand that technique? It's okay with you? Okay, now, do you know what could be the balancing fees for an energy supplier? So imagine we have already bought all of the energy that we need for our customers. So it's okay, we have the energy. Do you know what could be the balancing fees? Balancing, it means I need to balance on an hourly basis the consumption of all my customers and the energy supply. In your opinion, is it possible to forecast perfectly the consumption of the consumers? It seems difficult. Is it possible to forecast perfectly the production of the producers? It seems difficult. So probably as an energy supplier, I will make some errors on the forecast for productions and for consumptions. So probably I will have to pay something for that, for these errors. And then at the end, you already probably know that, but your consumption profile of the consumers probably will be different of the production profile of the producer. So how can I match the demand at all time? Maybe I will need to buy a different kind of energy product to match the demand. So probably it will have also. These are the balancing costs, balancing fees. So I will have a cost for the forecast error for production. I will have to pay something for the forecast error for consumption. And I will have to pay something because the production profile is different from the consumption profile. So first, let's focus on the balancing fee for the difference between the production and consumption profile. Here in red, it is a wind power production profile, and in blue, it is a consumption profile. You can see that the wind power fluctuates a lot. Sometimes you have wind, sometimes you have no wind. It's like that. Sometimes wind during the night, sometimes wind during the day. And the consumption profile is much more regular than the production profile. So imagine that you want to balance the energy produced by a wind farm to supply this consumption profile. You can see that here you will have too much energy, and here you will have not enough energy. So it means that here you will need to do something to supply this energy, and here you will need to do something to get rid of this excess of energy, because the TSO will tell you at all time it needs to be equal. If you are not equal at all time, you will have to pay some fines. So you need to do something. And so most of the time, you will sell this excess of energy on the energy market. And here you will try to buy the energy on the energy market, or you will try to aggregate several kinds of wind farm and PV farm to try to make a production profile that is more constant. But it has a cost. And one way to estimate this cost is just to make the difference between these two profiles. It is here in yellow. So you make the difference, and here you will trade that difference on the day-ahead market. It's a right way of doing it. And so you can compute this cost, you make the difference, and you buy it or sell it to the spot day-ahead market, and at the end you have your cost. It is a fine, the fee that you have to pay. And I made the calculation here with data for the year 2017, and for instance, it amounts for 24 cents, euro cents. And this cost, you will add it to the energy cost, 48 euros. But it's important as an energy supplier to make that calculation, because if you just sell the electricity to the consumer without the cost, you will lose money. Concerning the production forecast error, so you try to make forecasts on the energy production, but of course you will make error. It's the same thing. So at the end, you will have unexpected error, and so the TSO will make you pay a fine. It's like that. You cannot do anything about it. So one way of estimating that cost is to say, okay, this is my real production. This is the forecast of my production. I make the difference because my forecast is not perfect. If the forecast is perfect, it is zero, but it's not perfect. And I will imbalance. The imbalance price is a fine that I need to pay to the TSO. And so I can compute the difference between the spot day-ahead market and the imbalance, and to compute an average cost. And so I made a computation for wind power, hydraulic, and solar. And most of the time for wind power, as it fluctuates a lot, it's much more difficult to forecast the production. So you will have to pay, you will pay more fine to the TSO. And this cost, most of the time it is between 70 cents or 2 euros per megawatt hour. Hydraulic power is much more easier to forecast. So the cost is a little bit less, and the same thing for PV production. Have you ever heard before that of imbalance prices? Yes. In that course, I think I don't know what you have seen. In fact, in that course, if you have already seen how I think the clearing price for the day-ahead market is okay. You have already seen it, but I am not sure about the imbalance price, how it works with the
introduction course, we talked about it.
Okay.
Not in detail.
But you know what it is, in fact. Huh? It is a price. So the TSO has to balance for the entire country consumption and production. It has to match, otherwise it's a blackout. This is not what we want. And so the TSO, when it monitors at all times the production consumptions, it is never equals. So what it does, it tries to activate means of production if you do not have enough production. But so it means that you have to pay someone at the last time, maybe to start a gas power plant, for instance. But you need to pay that someone. And maybe if the production is not equal to the consumption, it is because the energy supplier has made some forecast error, and it's like that, it's life. So at the end, the TSO will have started a gas plant, and it will pay the energy supplier that has not well forecasted its consumption to pay for the gas plant. And it is paid through the imbalance price. So on a quarterly basis, the TSO make a bad job to balance the grid, and it defines the imbalance price. And when you are a gas supplier, you have a bill for the TSO that say, okay, for each quarter of each day of the year, at that time you had too much energy. At that time you didn't have enough energy, so you have to pay for that. You have to pay for that, based on this imbalance price. And here it's a snapshot. For instance, it was last week. And here you have the imbalance prices in blue. And here it is in euro per megawatt. So you can see that the price is very, very high. And it is normal because if the price is low, everybody is okay. I don't care about the fine. So it's not a problem if I make some error forecast. And here the price is very, very high. And here in orange, you have, in fact, it is the system imbalance. It means that at that time, for instance, on all Belgium, the system has too much energy, that amount of energy in terms of megawatt. And at that time, the system needed that part of energy. So you can see that, in fact, the demand is never equal to the production, and the TSO is trying at all times to make it match on a regular basis by starting over means of production.
Explain again how TCO decided to imbalance price.
In fact, it is based on this system imbalance. At all time, it is matching the system imbalance, so it is monitoring how much production do we have and how much consumption we have. It makes a difference. So it is here in orange the system imbalance. So here, for instance, for this quarter, it needs, I don't know, 300 megawatts. It needs that. And so the TSO will try to activate some reserve production. So there are some people that have some from power plant, and they are ready to produce, but they do nothing. And sometimes they receive a call from the TSO. They say, okay, I need you to start your plant. Okay, no problem, I can start it now, but you pay me. Okay, no problem, I will pay you that amount. And so this is how the imbalance prices are set up. And then the TSO will start this plant. So the plant starts and it tries to add some production to match the demand. And then at the end, the TSO will have a look on the detail of their system imbalance to see who was in default. Who in fact needed more energy than expected. And then we tell them, okay, you told me that you needed that amount of energy, but in fact, you consume more than what you just declared. So I will make you pay this amount of energy that has been compensated by another power plant at that imbalance price. This is how it works. And most of the time, the imbalance price is higher when the system imbalance is higher, because it's much more difficult to balance the system, and you need to start much more power plants. But it's a very difficult job for the TSO to balance at all time the production and the consumption of the country. And if it does not do that well, that job, it is a blackout, which happens very rarely here in Belgium. But in some countries, it happens quite. And here you can have access to some data on ELIA website, because ELIA is the TSO of Belgium, and everything is public. So you can watch at all time what is happening. So for instance, right now, you can see here's the imbalance price, here's the system imbalance. So here, for instance, it was maybe 15 minutes ago, the systems on whole Belgium has too much energy, 100 megawatts. Yeah. And in the morning, it was the opposite. The system needed energy. So probably here, what did Elia was to start some plants to try to balance. And here now it is doing the opposite to say to some people, okay, can you reduce your production, please? Because we have too much of energy. But of course, I will pay you the difference. But at the end, this is not Elia that will pay. It is the people that are that have made a forecast error on their consumption and their production. And so you can understand that with a system with much more renewable, it's much more difficult to balance the system, obviously, because if you have a lot of renewable, so wind power and the PV, they are uncertain energy. Sometimes you have sun, sometimes you have wind, and it's very difficult to make accurate forecast of this renewable energy. So for the TSO, it's quite a pain in the ass, in fact. Even if we want to have a lot of renewable energy, because we need that to decrease the carbon footprint of electricity, at the end for the TSO, it's very difficult to balance the system with a lot of renewable energy, because it fluctuates a lot. And that's why in a system with a lot of renewable energy, sometimes you need a lot of gas power plants, because the gas power plant, they can start and shut down very quickly. So for the TSO, it's quite nice to have a lot of gas power plant, because if they need energy, they just make a call, can you start please? Okay, no problem. And with a nuclear power plant, you cannot do that. It takes more time to start and to shut down a nuclear power plant. Or you need a lot of storage. If you can store electricity, it's very easy to balance the grid. And one way, the best way to store electricity, do you know what is the best way to store electricity? Hydraulic, and you? Hydraulic, yes, hydraulic dam. Just there, and you just push a button and the water goes through a pipe and produce electricity. It's magic. In a few seconds, you can produce the exact amount of energy that you need. So hydraulic dams are the best way of storing energy. But the thing is that in some countries, you do not have enough hydraulic dams. For instance, in Belgium, we do not have a lot of hydraulic dams. We have the power station of Co. Probably you know it in the Ardennes at Co. And it is quite a big power dam. And in fact, they have two main reservoirs. I don't know to say that. And they can pump water from the smaller storage to the upper storage. And like that, you have some water here. And when you need it, it goes through a pipe and it will produce electricity. And it has an installed power, I think, of 1 gigawatt. So it's quite a good one. It's like a nuclear power plant, but you just press a button and you have some juice into the grid. But some countries, they do not have anything. And in some countries, they have a lot of hydraulic energy. Okay, so it was just to explain you a little bit that. But let's come back to what we were doing. Now for the consumption, also obviously the energy supplier will make some forecast error, because even if it has access to the synthetic profile, in reality you will have some small deviation from the synthetic profile, because sometimes people, they do not behave as expected, of course, because just imagine you are in winter and you make some weather forecast, but the weather forecast are not perfect. And the day, in fact, is much more colder than you expected. So you heat more. So you will make some error on your consumption. And so at the end, it's the same principle that for the production, we will pay some fine to the TSO at the unbalanced price. And so as an energy supplier, you need to anticipate that cost. So you can make that kind of calculation. And you can anticipate that, for instance, the cost will be of 70 cents if your forecast is not too bad. And so when you will make the contract with the consumers, you can put that cost into the price. Otherwise, you will lose money. Okay. Okay, so we have seen two ways of computing or estimating the energy. We have seen how to compute the balancing fees. And now imagine that you want to make a green offer. You need also to buy the guarantee of origin. So for that one, it's quite easy. there are some markets to buy guarantee of origin, and so you go to the market and you say, for instance, I would like to buy a hydraulic guarantee of origin. Someone will say, okay, I have hydraulic €2, okay, no problem, and you buy it. So it depends on the price of the guarantee of origin. You have a market for that. So you buy the guarantee of origin that you need, and at the end, we put that cost into the deal. And most of the time, the price is not too high. It is between 50 cents or €2 per megawatt. Because compared to the energy, that is between 40 and 50 euro. It's not so much impact. Okay. Now the last cost. I think you do not know about that, the capacity market, but I will try to explain it quickly. It has started in France, but it will also it will also happen in Belgium. And so the goal of the TSO is to balance the grid at all time, especially during peak hours. And for the TSO, it's difficult to balance the grid during peak hours because sometimes consumption at the country level is increasing very quickly. And so this is what happened inside the day. So during the night, the consumption decreased. In the morning, you can see the difference here. So between 6 a.m. and 10 a.m., the consumption can be multiplied by 2 or 3 or 4 during winter. But imagine that at the country level, here we are speaking in terms of 10 of gigawatt. So like that, in 2 or 3 hours, you need to go from 10 or 20 gigawatt to 40 or 50 gigawatt of electricity. So it's the equivalent of a dozen of a nuclear power plant, just like that in 2 hours. And the TSO has to balance that, and then during the day it decreases a little bit, and then during the evening it starts again. There is a peak, and then it decreases. Sorry. And so the TSO has to balance the grid. It's like that, and so it will try sometimes to encourage the consumption saving by telling to some people, say, can you decrease your consumption, please, because here we are consuming too much, or sometimes to help people to make investments in a power plant that will be used just only during the peak to help to balance the grid. And to do that, they have designed a capacity market. And the capacity market is a way to help some actors to build new installed capacity just to supply energy during the peak. And if you just rely on renewable, it's very difficult to balance the energy during the peak, because you cannot say, I want wind at 7 p.m. I want wind at 8 a.m. Only God can do that if God exists. And so for the TSO, it's difficult to cause that. And so the idea is, if you are a producer, the TSO will say, imagine you are a gas plant, you have a gas plant, so you manage a gas plant. The TSO will tell you, okay, your gas plant is quite good because I know that you can start very quickly your production. So if I need you, I can call you and I know that you can start the production, so you can help me. So the TSO will say, okay, I can estimate the potential of installed capacity that you have that can help the grid during the peak. And so you will have some money for that. So it's a way to encourage people maybe to build more gas plants. That will be just used during peak hours. On the opposite side, the PSO will have a look at the energy consumption of the energy supplier and will say, okay, depending on your consumption profile of all your consumer, I estimate that you need to buy some capacity. So it means that I estimate that maybe your consumption profile is very volatile, and sometimes I can see that you have very high peak of consumptions. So I want you to buy some capacity to prevent from a risk of not delivering electricity at that time. And so this money will be given to the producer, and it will help them maybe to build enough capacity plan that will be just used during peak hours. This is the basics of the capacity market. And so, for instance, in France, 3 years ago, a capacity for 1 megawatt was sold 10,000 euros on the market. And 1 year ago, it was between 20,000 and 50,000 euros per megawatt. So it means that the capacity price has increased. Why? Because there is a need, an increasing need, for new capacity to help to balance the grid. And why is there this trend? It is because we are installing much more renewable. So as the share of renewable in the electricity production is increasing, it means that the TSO has much more difficulties in balancing the grid. So it needs more capacity to help to balance the grid. And this is why most of the time in country where the share of renewable is increasing, most of the time you have new gas plants, power plants. But in terms of total amount of production, they will not produce a lot. They will just produce a tiny part of the energy during peak hours. But so that's why the total installed capacity of a gas plant is not decreasing as we increase renewables. In fact, it tends to increase. But at the end, maybe they will not produce a lot, but just during peak hours. And this is one way to help the system to do that. Or maybe to build new storage system. And so in Belgium, it is the same, but it is called a capacity remuneration mechanism. And here you have a short video from Elia, 3 or 4 minutes, that will explain you the principle, but you can have a look at it, but the principles are the same. And in fact, Elia has put in place a system because Belgium is supposed to phase out from nuclear in now 4 years. So it means that probably the system will need new capacity also, not only during peak hours, but also for production. And this is one way also to encourage new actors to build new capacity, but probably it will be not only a renewable, but also a gas power plant. But you can have a look at the video, I will show you. So in conclusion, what you need to bear in mind is that the energy part of your electricity or gas bill amounts for approximately 30 or 40% of the total. And the energy supplier can only optimize that part. It cannot do anything about taxes and transport or distribution costs. And for that energy part, you have several subcomponents. You have the energy that you can buy on the energy market or directly to the producer. You have the balancing fee. So you have to make forecasts for consumption, for production. You have to try to balance the energy that you have and the consumptions. If you want to make a green offer, you need to purchase some guarantee of origin, and you have also to comply with the capacity mechanism that is a legal obligation. You have to buy, as an energy supplier, some capacity with this mechanism to help the TSO to balance the grid. So this is the end. Do you have any question about this one part, which was maybe a little bit more technical than the first one, but just to give you some insight. In reality, it's much more complex, but the principles are the same.
Why Belgium absolutely wants to invest in the gas pickup line to phase out nuclear and not invest more in energy storage like batteries or new dam? Or...
Yes, okay. So in fact, it is not written like we want more gas plant, but the capacity remuneration mechanism will help to install new capacity. So it could be gas power plant, but it could be, as you say, new storage system. But the thing is that from a financial and economical perspective, it's much more profitable right now to invest in a gas power plant than in a big storage system. So you can invest in a big storage system, but try to compare the power of a gas power plant that could be hundreds of megawatts, and the equivalence in terms of storage system is much more expensive right now. But maybe in 5 or 2 years, it will be different. But if you have a look at the price of the storage, it's very difficult to buy the storage system that can deliver, for instance, 500 megawatts. Most of the time, only the hydraulic dam can do that. And here in Belgium, we have already one in Co, and I think it's not possible to beat them. Yes, they already do that, in fact, but they are a little bit less powerful than Co, but they already do that. Sure, yes, I did not mention the pen. Other question? Any other question? You will be soon delivered, but Antoine will speak to you before.
Let's thank Jonathan for the great presentation.
Great, I don't know, but I hope you understand some things. So the slides are already on the website of Damien, and